Got a SUNN Concert Keyboard amp in for service. This one's humming because it doesn't know the words. And the client wants to see if we can get this hum under control. So this one's going to probably need a bunch of caps in it. Let's check it out. This time we've got a SUNN 200 watt power head. This is a type of amplifier that would be used with a bass guitar or a keyboard. And this one here, the complaint is that it doesn't know the words. In other words, it hums. Take a listen. Do you hear it? I'll kill the radio. Now, listen. Hear it humming? That's what it's in for. So let's open this one up. Start doing some troubleshooting. It's going to be filter capacitors for sure. It's going to be a leaky cap, either in a regulator circuit or could be even the main power filter. But let's get this one open. This one should come apart by just removing the 4 screws in the top, as these units usually will just slide right out of their cabinet. That should push the amp out from the front. This is a solid state amp, this one, with a reverberation spring in it. That's the reverb cabinet. For those that think these are a very complex amplifier, think again. They're actually relatively simple. If I turn on the reverb, if I pluck the reverb strings, here's some. That's just turning up the gain on the reverb amp. This is normally isolated, and people would bang these things and they make lots of racket. We got dirty controls for starters, but you can hear some noise here. This is going to need caps for sure. Big filter caps are probably okay. It's more than likely some of these small ones in the preamp is where it's going to require capacitors. There's not a lot to these amplifiers, as you can see. Controls need to be cleaned for starters. His complaint was humming, and that's probably the humming he's talking about, is the hum that I'm getting through the preamp. Of course, I've got the volume turned all the way up to like 10. Probably not a good place to be. My speakers would check out pretty quick. This is a 200 watt amplifier, mono of course, right? So it can deliver up to 200 watts, and that speaker itself is rated for probably 50. I always found the reverb cans kind of interesting. I used to have an old organ, an old Hammond, that had one of these in it, and I sold the thing. I should have kept it because it was an old classic. It was an old Hammond that had belonged to a relative, and I fixed it all up. But my kids, when they were little, all they were interested in doing was making noise and driving the neighbors crazy. So I put it up for sale and sold it to a musician for, I think, $500. And he came out and he couldn't believe how good a shape this thing was in. But it had one of these in it. I was always interested in how these things worked, and they're really quite simple. So basically what you have is 2 sets of transducers. One acts like the speaker, the other one acts like a microphone. And your signal gets applied to one side, which, think of this as the voice coil. And it sends the musical signal into this spring. And it delays it as the sound vibration is moving through this spring. It's becoming very reverberating. and then it's picked up by another coil on the other side, which acts like the microphone. So think of it like a speaker with a long springy spring between the two and a microphone. And the longer this, the longer the delay will be. I always was intrigued by how they worked. And then, of course, this was isolated in like a rubber shock mount. I think if you shout it, you can probably, if you're able to shout loud enough, you probably hear your voice. Hello! See? How are you? They're just acoustic. They are kind of neat, the way that they operate. And of course, people would do things like they'd bang the amplifier, or in the case of this organ, if you banged it, you got lots of noise. Fun to play with. Anyway, I think first things we're going to do on this one is I'm going to clean up these controls, because these controls are bad to begin with. So let's get the neutral out, and we'll clean up the controls and then see how this performs, or see how it sounds as far as it humming goes, because that might be his problem. Or we may have to change some of these caps. I think the big ones here, they're probably okay. If they were bad, we'd hear a lot more noise than we hear off this thing now. I think that very well could be either some of the preamp caps or just the controls themselves. But we'll start by cleaning up the control. To gain access, I'm going to take this section out. I'm going to take out the reverb can. We'll just remove the screws that hold it in place and flip it out of the way. That way I can access the controls a little bit easier. Yes, the power is off, by the way. Now, I remember that this is exactly the same reverberation device that the old Hammond organ had in it. I remember that very clearly. Folded line, manufactured by beautiful girls in Milton, Wisconsin, under controlled atmospheric conditions. It's got an input and an output. That's the input side, and this is the output. So this is the speaker side, and that one there is the microphone. So this is the input side, feeds into this. This is the equivalent of the voice coil. It vibrates to the sound of the music, sends it down this long spring where it comes back on this side and then reverberates over to here and is picked up by this coil. As you can see, this whole system is shock mounted. There's springs on all four sides, springs down there to hold it up, so it's suspended by springs. Anyway, I'm going to clean up these controls, and then we'll see how this thing performs and what it makes as far as noises go. And then we may end up just having to change out some of these caps in here. We'll do these ones. I'll have to get some. I don't have the values that I will need for this. Most of these are relatively high voltage, like 100 volts, 10 microfarad. I don't have any of those. So we'll clean up the controls and see how it sounds, and then I'll get some caps in and we'll change them out. I don't think we're going to have to change these ones at this point, but certainly these other ones here, we might want to just look into replacing them. Nice thing about systems like this is that the controls are easy to get to clean. So it's easier by turning the amp onto its side to get access to the controls. It's going to bend the tip of my little nozzle here so that I can blast the controls, get some cleaner into them, and then I can just give them a rotation and clean them up. We'll do that first and see how it sounds. I was telling the guy that owns this, I said, if I have to get my bass out and play it, he's encouraging me to, but no, that's not going to happen. I play guitar, or I played guitar and bass, but I haven't picked it up in probably 10 or 15 years. At least 10 years. I don't think I've picked it up, so I don't think you guys would want to hear me play. It would be embarrassing. It'd be embarrassing to me, and it would be embarrassing to you to listen to me play. But I could play at one time. Okay, we'll power it up again. This time I've got the preamp unplugged so that the controls are completely disconnected. See if it's still going to hum. I still hear a little bit of a hum. So that's going to be in the power amp. So we're going to change the caps in here. And the main filters are probably okay. We can look and see if there's any AC ripple getting through them, but unlikely that we're going to detect any AC voltage. We've got the meter in AC mode, and we'll just take a look. So our ripple is like 0.1 volts, so 0.093 volts AC. So it's unlikely that these ones are causing it. If we look at the voltage between the two, got 0.2 volts ripple between the two. Now, by comparison, this is our rail, our negative rail is 37 volts. Our positive rail is 37 volts. So this isn't even that high a voltage here between the two of them. It's only 75 volts. Not that much power when you think about it. Like, there's a lot of amplifiers out there that have a lot more than that. 160 volts between the two rails. This is relatively low voltage. Like, this isn't even hazardous. You put your finger across here, you're not even going to get a shock. But let's see how quick this thing drops off. So say these are not that big a caps. As you can see, the voltage drops off pretty quick, and that's just due to the internal bias of the output transistors. They're always going to be biased on a bit because it'd be a class AB amp, so you've got a little bit of idle current, which will of course pull the capacitors down real quick once the power is removed. 37 volts. That one's going down real quick. And I'm sure if we measured the capacity, which we can, is have to disconnect the wires, we can measure the capacity of these capacitors and just see what they measure. So this cap's 6800 microfarads. Let's just see how it measures up when it's disconnected. $6,900. Yeah, I think we're probably okay with this cap. It certainly has not lost capacity. We'll do the same for the other cap. Negatives. The negative side is $6,800. So, capacity-wise, both caps are measuring to spec. I don't think our noise is coming from these. It's going to be one of these small ones. So that's where we're going to go. We're going to go down that road and replace the small caps on this one. So we're back on the SUNN amp. I made a special trip out to RP Electronics. I give them a plug because I know the guy there who was telling me watches my channel. So I will give them a plug. I went to RP Electronics and picked up some capacitors to replace these ones. Got a couple of axial lead. I was trying to get them all, but they didn't have them all axial lead. But I got some good, higher rated caps than a lot of them. And I didn't have, some of these were higher voltage caps. 63 volt and 100 volt, which I didn't have in stock, so I had to go and get them anyway. So got a whole series of caps. We're going to change all these caps out on the preamp and the power board. I'm not going to change the big filters because I don't think there's any problem with them, and these will be quite expensive to replace them. These ones were bad enough for what these cost. It's been a while since I've bought capacitors, and trust me, they've gone up in price. So we'll start out with the preamp board. To remove the preamp board, I'm going to have to remove the controls and take off the nuts, because that's what holds this board in place. So we'll start by removing the controls themselves. Be really careful on these. The last thing I want to have is to have this skirt with the numbers on it snap off. That's always the worry when you're pulling knobs off. The thing I am going to do is I am going to reseat the sockets for the transistors. I'm just going to move them up and down a few times in the sockets. This way it will clean off any oxidation that may have formed on the transistors themselves, and of course in the sockets. Socketed components were great for ease of replacement, but the problem with socketed components was there was always a point of failure between the lead and the socket itself. So when you see socketed transistors, it's usually a good idea just you don't have to unplug them completely, just move them back and forth a couple millimeters. That way the contact action between the actual spring clips in the socket and the leads will clean off any oxidation that's on them. So first things first, I'm going to remove the knobs, or remove the screws, the nuts from the knob, and then I should be able to flip this board out of the way to change these 5 caps. So give the nuts a bit of a turn there, and the nuts will come off, and then I should be able to swing the board out of the way. As I don't think there's anything else holding this in place other than the controls themselves. Board should swing back, and I can get it out of the way and change those ones. And then this other board here, there's just a couple of plastic clips holding this in place. I should be able to disconnect these leads here going into between the interconnect board, just unplug them, and I should have enough clearance that I can swing the board up out of the way to change the 3 caps on that board that need to be replaced. So, remove the washers. Right on cue, the heat comes on. I got to unplug just a couple plugs on here that are a little bit short. So I'll undo the black one and the orange plug over here. Where's the orange one? No, there's 2 black ones. This orange one's actually over here further, but undo the 2 black connectors, and I should be able to lift the board up. And I got to undo this blue one over here, the orange and the white for this is for the brightness control, and there's another white one over here that can unplug. And I think that should be able to swing this board up out of the way now. Oh, no, one more black connector down here. And now I should be able to swing the board up. A string here that holds the wires together. Cut that away. That way I can swing the board up and out of the way, and I can access the bottom to change out the caps. Look at the circuit board, it's beautiful. Looks like someone's done a mod on this at some point. But the board itself, very well built. So we'll start out changing this one here. I don't have the exact value, so I went up a little bit in value on this one, but that should not be an issue. Just a filter. So we'll remove this one. Well, the next one I couldn't get an axial lead cap, so I'm gonna have to use a radial on this one. It's 1000 microfarad, 63 volts is what I got. This original was a 50, so going up in voltage is a little bit, it's okay, we can do that. Not going to hurt anything. But on this one, it's going to be a little more of a challenge to install it, just because of the lead length that I need to get to. But unfortunately, I couldn't get a cap of the same style. I tried, but no such luck this time. This one I may have to lay flat because it's got to have the reverb device sitting above it. There's probably enough clearance though, but I may have to bend this one over a bit once it's installed. But I should have enough clearance here to put this one in, no problem. Next is the 10 microfarad 100 volt. No such thing available, at least not at RP. I had to buy an expensive 10 microfarad 450 volts because that's all that they had. And these, when you get into these higher voltage caps, they actually get quite expensive. Why they've used such a high voltage cap in here, I'll never know, because there's no voltages even getting close to 100 volts in this amp that I'm aware of, but that's what they put in here, negative and positive. You gotta be careful on this one because this lead is not to touch that. It's a different trace. So I'm gonna have to kind of push this one over a bit this way just so that I've got good clearance and nothing's gonna touch anything that could cause a problem. So we'll just put that one over like that. And finally, the last two on this board. These are just small 25 volt 10 microfarad caps. It's another radial lead cap, as I didn't have, or they didn't have any axial lead caps in the voltage I needed.
So that should do it for the preamp board. We'll get to the power amp board next. I'm just going to remount this one and plug everything back in. And then we'll get onto the power amp board, and that should do it for this one.
Okay, put the knobs all back on. These are all keyed knobs, so they only go on one way, which is nice. Go. All right, now time to work on the main power amp board.
First we'll plug in all the plugs we undid to service this board. The orange and the white won't really matter because they're just going to the bright switch, so it's just an open and closed connection. And then we have our two black wires over here and one more white wire. And that's got this board reconnected. We'll do the same for this other one. Shouldn't have to take out too many plugs on this other board. Possibly just these ones here. Maybe not. Maybe just the black and the orange and possibly the red. The rest of them, and this one over here. The rest of them, I should have enough clearance that I can swing the board up. So we'll start by popping out the plastic clips that hold the board in place. Squeeze them with a pair of pliers and they'll lift off as a rule, like that. And I think it's just the two on the other side. I think these ones in the middle here are. That one might have to come out. I think that one has to come out, and then these two on this side over here. This one here is not attached to anything. It's just a spacer to prevent that board from sagging. Okay, I should be able to lift this up now without removing too many of the wires. I don't want to have to remove all these wires and put them back on, just the ones I need to swing to get out of the way. And since there's an extra connector here, I'm just going to mark these ones as to what's coming off what with a felt tip pen. That way I know where they go. So I've just labeled the plugs that I'm going to undo so that I know which ones go where. And I shouldn't have to take off anymore. I think that I can probably swing this up enough now to access what I need to access, which is just these three caps, and I've got axial lead caps to replace them. Same value as the originals. So let's change them out. Oh, these are probably glued down as well. The other ones were glued down, so I bet these ones will have to break the glue bond. There's one. next one over here. Nice symbol on the bottom of the circuit board here. Okay, next cap goes in. I got that hole cleared. And one more, and that should do it for the recapping of this SUNN Concert Keyboard amp. And this one goes in the opposite way with the positive facing towards the rear of the unit. Gonna line up the mounting clips. Just push the board back in place until it locks and seats, and then reconnect the wires. And this one is over here. I think that's all of them. And we'll just make sure that those transistors are still seated properly. Make sure that they're all in place. And finally, I'll put the reverb can back in place, and then we can test this unit, see how it performs. Okay, let's fire the unit up. See if it hums. Don't hear any hum yet. Hear the treble control. That was the volume cranked all the way up. That's the crank up the bass. Okay, let's plug something into this thing and make some noise. Alright, I got this thing plugged in and turned on, and I'm going to make some noise. And I'm not going to make some noise with my guitar because you don't want to hear me play guitar. So I've got my synthesizer that I also haven't used in years plugged in. And we'll see if this thing makes noise. Yeah, it makes noise. I don't have much of a speaker on here, but it's pretty loud. I'm going to say that this one's done. This one's working. I don't hear any extraneous noises coming out of it, unless I crank the crap out of the reverb, and I hear a little bit of a hum if I crank that all the way up, but that's to be expected because I'm picking up noise just from in the shop here. Anyway, it's a lot quieter than it was when I started, other than the noise that's actually in the shop right now. If I shut everything off in here, other than the fan that's in the monitor, this thing's pretty quiet. Unless I crank the volume all the way to 10. And then we're hearing the preamp noise. I'm going to say this one's done. And for you guys with a sharp ear, I'm not going to tell you what type of synthesizer that was, but anybody who's got a tuned ear probably knows what I was using. Try to guess what make and model of keyboard I was using without me showing it to you. And we'll catch you in the next one. Bye for now.